Hello. So I know this is going to be a fight between me and the coming lunch. So I hope I'll keep your attention, and I hope to deliver something that will share some useful bits at least. So it's about transforming your data with Ruby and a gem called ActiveWarehouse-ETL, which is not very known actually, and the word ETL is not known either. So one of my goals for this presentation is to at least transfer this concept, so you know you can find books and existing literature to impact your daily work. So you can hit me up on Twitter or GitHub or whatever later if you want to discuss more advanced topic. So you get an idea of the outline of the talk. There's a first part about the concepts and about a beginner example that you'll be able to find on GitHub later. So you can follow with a very basic sample. And then a second part will show you a more width of example of scenarios that you can cover with this kind of techniques. So first, a quick poll. Who knows what ETL means in the room? So I'd say about 15%. Right. So it's extract, transform, and load, and it's a very widespread term. And that's the keyword you should use on Google if you want to find more patterns like the ones I'm going to present today. So extract, what does it mean? It means that you're going to take data from a local database, a remote database, a CRM, ERP, or other kind of systems. Or it can be partial or complete, so you can have only the differences or the full extract. Transform, by transform we mean sometimes you have to clean up data, look up between table, enrich things, complete things, filter, remove, conform, which means giving the same name to things that are slightly differently named, and normalize or denormalize. And then the L for load can mean dump to a file, for maybe sending it by email, that happens. Insert into a database, or another keyword that I may learn to you today is upsert, so update or insert. So how to handle something that is respectful of the current state of the destination. I didn't invent any of these. If you really want to have a good read about the subject, I can warmly recommend the book by Ralph Kimball, which is the Bible in this domain. It's a fairly old book, so it can be a bit dusty for parts, but you will find a lot of things. Then, as I mentioned, I'm going to talk about a gem called ActiveWarehouse-ETL. It was first released by Anthony Hayden here in 2006. And then it really became fragmented on GitHub over the years. So I picked the maintenance last year to grab all the forks and bring back the commit together so we can hopefully use it again. And the latest release, 1.0, was just last week. So it's a very slow maintenance gem, not very well known, and you can find more information at this URL down there, activewarehouse.info. It works on Ruby 1.7.193 and Active Record, the most recent versions. So how does it work? Basically, you install the gem, and you have a binary command called ETL. You create ETL scripts, which are Ruby declarative scripts. We call them control files. You have a bit of configuration, and it can work in an existing Rails app or outside if you're not into Rails these days. Now, to bring an example, you will be able to find this sample, which is a very basic sample on GitHub. It works, and there is a more advanced one as well. So we're going to walk through this situation where you have a CSV file on the left, and you want to clean up and merge that data in a customer table in an existing system. So we're going to have 3 steps I'm going to describe. First one is 3 goals I want to reach. First is absurd based on email, which means consider that if 2 people have the same, if I do run the ETL process 2 times, I don't want to end up with 2 Bill Gates in the database, but only 1 based on email. Then I want to extract the email host to provide some statistics on the host, like Hotmail, Gmail, etc. And not Hotmail, I'm going to remove some rows. So it's a fairly basic sample, but I hope you will get a better idea of how this thing works. So that's our data. So first name, last name, and email. It can come from pretty much anything. I mean, a partner who is bringing you data, or a legacy database that you have on, you say your company developed a Java application in 2000 and you want to migrate it over Rails, for instance. And now straight to the ETL script in itself. It's something that is a bit hard to grasp at first. This is the declarative nature of the gem. So you really have a DSL to declare and transformation, source of data, transform, and destination. So this is the example of the data source. This one is going to be called input. The thing, do I have a? Yeah, it works. This symbol here can be replaced by any class that you can write to extend the behavior. Let's say you have something very specific and you want to deal with it differently, you can extend it and replace put a class name here. So we're going to skip 1 line here, and we say that we have 3 columns that we had in the file. Then we're going to declare transforms. This one will create an email provider column. And then you have a block transform, which will basically take the raw email, a row being a hash, actually, a Ruby hash. Put it to downcase and grab the last part of the email so that we can keep it in a separate column, because that's what we want to do. So one thing you really need to understand is that when the script is loaded, this code is not actually executed, because it's going to be processed for each of your source rows, and you can have many, like million or so or more. It's just adding, like a bit Xavier was describing earlier, the constant table. It's adding a transform into a lookup table, a table of transform for later processing by the engine. Another kind of transform, you saw the block transform just before. This one is, this still the name of the field we're going to create. And this is the built-in transform name. So this is the default transform, which will make sure that if you have no value, a blank value in the field, you will be able to replace it by unknown. So you have pretty much a lot of transform built in ActiveWarehouse-ETL. They can do things like lookup, transcoding, transforming things into with decoding tables, things like that. And another example, you can refer to multiple fields if you like to concatenate 2 fields and joining them. It's pretty much basic Ruby in there. So it opens a lot of possibilities. Then you have, sorry, as you guess, I'm a bit ill. You can have as well a row processor, like before writing to the destination, you're going to remove the rows where the email provider is Hotmail, because we decided those rows are not interesting. So I use here a simple transform to return nil if the email provider is Hotmail, which basically removes the rows from the pipeline if they match these conditions. And last, we're going to declare a destination. So here, this is again referring to a class name which is a built-in destination in ActiveWarehouse-ETL, but you can write your own, and that's actually the advice I give. You can have a look at the available transform, but more often than not, it's easier to build your own stuff to match specifically your needs and use ActiveWarehouse-ETL as a global framework, so to speak. And here it refers to the active record configuration in the database YAML file I mentioned earlier, and the table, and the primary key which will be used to replace. So basically the record won't be added if someone with the same email is already in the database, rather it will be updated, so that's a fairly common pattern. And then to show you, we can use arbitrary Ruby in the middle of the script. I can declare a customer active record, then use it. And the screen is another construct which will let you make checks. You can use test unit in there to make requests against your database or other items you're processing, and stop the processing completely if that's what you want. So here we make sure that over the time we still have only one guy with johnbarry@gmail.com email. It's to make sure our upsert work properly and we don't end up with duplicate records. So there is a lot more actually in the pipeline of ActiveWarehouse. First, the file is evaluated, which means you can do some interesting stuff like parsing files yourself, creating a list of files from an Excel file, and do all kind of fancy things. Then you have a pre-process step, which means you can transform, for example, data from an encoding to another, make sure you have the right structure at the right place, or I don't know, extract extra data from elsewhere because you need it. Then the sources, like the source I described, I showed you earlier, are evaluated. You can have many sources, and the rows are yielded like in Ruby. They go through the after read, the transform, the before write. The after read is a bit like the before write, except it occurs right before the transform. And finally, return to the destination. Then after that, you have two important steps that you can use to provide data quality, such as making sample queries to your database to make sure you have a right data at the right place, or making more statistical requests. Let's say, for instance, you have geocoded items. You want to make sure that maybe 90% of your items are properly geocoded. You can do that with this step. Now to the key point of using Ruby for that kind of processing. First, it's highly hackable because it's Ruby, which means you can reuse existing gems, you can inject your classes, you can unit test. It's fairly important to have a good quality. You can make diff between your ETL script. It's something that is not very common because many ETL tools from vendors are more graphical. And sometimes you end up diffing weird XML files with metadata, which is a painful experience. And you can as well compose. You've been there. And as well, you can compose. If I go back to you see these transforms, I can create a method that will declare the chain of those two together. So I can reuse elsewhere. So that's really the same tenets as well when you're developing real codes. Oops. Getting there. The declarative syntax at first looks like a funny thing, but I've been talking with people handling hundreds of scripts like that. And they are really thankful because it's very concise, so it's easier to maintain, easier to reuse over the time, especially with less technical people, which means you can end up delegating this kind of job to people that are just beginning to program and keep the real Rails expert where they belong. And it's row-based processing. It can appear like a detail, but it provides a strict framework, and as we know it, strict frameworks provide as well creativity. So you can end up doing more things because we have been telling you it's like that, and then you can reuse more, you can benefit from existing pattern more. One drawback, I'm going to point out two drawbacks. The docs kind of suck for the moment. This is something I'm going to work on. So don't be afraid of embracing the code. The code Anthony wrote in 2006 is still fairly readable. Thank you. And Ruby is really slow. It's much more slow than for web apps, like a ton more slow. It's not something that is Ruby is not planned for data processing. It's really a flexible language. But I can tell you that it's more often than not, it's not really an issue. I've been talking with people and implementing myself on systems. People are handling like 50 million rows per day without much sweat. So people, I noticed that people have a tendency to overestimate their load, and in the end, sometimes they bypass using Ruby for that where they shouldn't. And then, if it's too slow, like I wrote here, it's still possible to delegate the critical loop like you would do in regular Ruby with some C code. You can delegate a critical loop to a more specialized tool like Hadoop or whatever fits your bill. And then again, you can use as well the features of your database. Not that many people know that, for instance, MySQL is able to do the upsert that I described earlier. MySQL is able to do that with on-duplicate key update. In SQL Server, you have plenty of tools, a tool called Merge for that. So know your database, because if Ruby is slow, you can leverage the database and keep Ruby as master of command. I've been implementing fairly large systems where Ruby was kept for the whole ceremony, and then delegate to something with a raw power when you need it. So that was the basic example you can find on GitHub. Hit me if you have got question later on that. Now, what you can do with those concepts and these tools once you master it. The first use case is reporting and business intelligence. Basically, being able to ask analytical questions to your database and your data. One key point is that you can start doing this on your production database. We've all done that at some point, querying your database for, I don't know, the sum of amounts of orders in that period, given these conditions, and then at some point it becomes fairly hairy, and you start having a slowdown on your production as well. When you reach that, it's a trigger. You have to realize that you have to, most of the time, split or find a specific tool for the reporting. And there is a tool I want to share with you. It's called dimensional modeling. Because your production system is built to be fast when the guy is going to do a transaction, like load a web page or pass an order or buy something. You don't want him to be slowed down, so you make design decision in your database to handle those cases. But when you want to do analytical queries, you need a system that is designed a bit differently. Let me pick a concrete example. Here you have a fairly typical dimensional model with a purchase fact, which is one record for each purchase, maybe with an amount, a quantity, etc. And then you're going to build dimensions, which are tables specialized for the reporting. And then you're going to use what we call a surrogate key to link the fact to the dimensions. Once you have that, even without going with an OLAP solution or more advanced solution, by joining those tables, you're already able to go a fairly long way in terms of reporting. Let's pick an example with the date dimension. Here, a dimension like that we would create with ActiveWarehouse-ETL would look this way. First, a technical key that the purchase fact table will point to, and then fields that are designed to make it easier for a non-technical person to create queries. For instance, the guy is not going to concatenate two fields to get the quarter and the year together. And you can have more advanced pattern like where we, in the middle of moving the company through files. And then the guy is going to be able to filter on that. Or so you're able to, using Ruby or a different solution, you're able to provide a more complicated columns to your reporting that would be completely impossible to achieve with your production database. Another example with a customer dimension, say you want to drill down a bit, or you want to slice the purchase by language or by country. If you do that in the production database, you're going to add unnecessary field and overload the database for nothing, while you can use a different server with a specialized schema for those questions. This way you don't interfere with production. How do we get there with ActiveWarehouse? We can use what we call a lookup. It's this one, foreign key lookup. So you're going to copy the created at Rails app field to data ID, and then you're going to have a lookup into the date dimension table so that you can replace the field by its ID, so you can have faster joins. All those techniques are, again, described in another book by Ralph Kimball called the Data Warehouse Toolkit. It's fairly old and getting older book, but there are plenty of books on the topics. But just grabbing, I think, the basics that are described in this book can help you provide, analytics for your next product or stuff like that. If you need to go further, there are some good solutions with OLAP. You can use, who knows who is OLAP? So to make it simple, these are specialized tools to make it easier to aggregate, filter, and roll and dice your data. The typical example is purchase by year, by area, by delegate, by team. And so if you want to dive, be sure to check out this address. It's a guy who provides a JRuby wrapper around Mondrian, which is a Pentao item to provide OLAP. So this was the first real-life example. Another example is the extracting and geocoding situation. Say you have a CRM or whatever your internal app to handle your customer and partners. And it's inside your network. It's not on the internet. You want to keep it there and not mix things too much. And on the other side, you want to provide a Rails 3 app that will be able to let people find around them where is the partner. And you want to keep that in synchronization. The first solution is to buy a module from the CRM vendor or create some custom Java code, maybe if it's written in Java. The other solution is to do that. It's to create full export from the source database, like flat files. Then use Ruby or another tool to clean and geocode using whatever API of your choice. And then push to production via SCP or another tool. And then use an import and indexing via cron, which means basically you can deliver a lot of value because you will keep always up to date, for instance, stores or partner lists always around, but you've been able to do so with Ruby, which is a lot faster and a lot fun to use as well. So in that case, we would use a before write. It's a very, very simplified script. In that case, it's a real-life example. I had to create a fairly complicated, elaborated geocoding strategy because you could geocode once and it would return garbage. But you could detect the garbage and then do something about that and reissue another geocoding query. Then you want to cache it in Redis so you don't explode your Google Maps quota. So that's the kind of flexibility you can have. Another common pattern, the third, is translating. On your left, you have a fairly oldish Java system. We don't have the documentation. People are gone. It's speaking Spanish. And on the right, you have a even older COBOL system. Who only understand fixed width files with very strict restriction. Otherwise, you will blow up the whole chain. And they don't have developers anymore at all, or in 6 months. That's a true story. Okay, not kidding. So this is something that rings a bell. You have two systems that are fairly rigid, and you see the situation. If I put a bit of Ruby in between, would it be nice? And it ended up fairly well. So you can create a well-tested destination, like I showed you earlier, with Ruby, and use Active Warehouse to provide a bridge between the two systems, as well in real time. One of the benefits of using Ruby for that task is that you can provide high-quality solutions. Between those systems, the kind of interop is always full of bugs. If you've been doing interop, you know what I mean. So I really wanted to be sure that, for instance, in the first case, we had /r/n on the end of lines because the COBOL mainframe wouldn't survive otherwise. And the second part is that we should really be warned if the data is too long, because otherwise the COBOL will truncate the data. So you can really have a test first experience doing ETL work with Ruby. And in that case, the raw performance you would have with other tools is by an order of magnitude better when you use that kind of technique. Another real-life example. Some people I know are using all the sources around them, AdWords, analytics, their phone calls, their app, but they want to consolidate all the data in one central place, and then they change their bidding strategy on AdWords. So it can be used to provide real-time, decision over your whole system. And another pattern, almost the last one, is aggregating data. I know some of you in the room are doing that. Let's say you want to create a hotel or a rental site. Like you want to provide a consolidated experience to the end user where you have 3, 4, 5, 10 partners. The first partner is going to bring CSV data, the other one XML, the other one rotten CSV, where you have to do all sorts of workaround because they provide duplicate and wrongly formatted data, all in the same site. Then using Ruby and ActiveWarehouse-ETL, you can merge the data to a common schema and then bring it into your Rails app where you can index the data and provide a good experience. Another pattern is that you still have the old CRM or fairly old app that you don't know how to extend too much. How can you clean existing data in the CRM or extend it with Ruby gem functionalities? It's a bit similar to what I showed earlier. You can extract the rows. In that case, I had IBAN bank account numbers. So the guys had corrupt data in their CRM, but they didn't know how to clean it. So I suggest that we extract the rows, write down the correct IBANs, so the bank account numbers, using a Ruby gem, because you can find everything in Ruby gem, really. Then craft an email to the supervisor so he can act and ask the team to correct them, which means getting in touch with the partners to get the right data. It mostly goes like this. So I found a gem called IBAN check. I made maybe one commit to correct the behavior. And then I just use a simple variable And if here you got the IBAN check call, if it's not valid, I just add it to a list, and then in the post-process, I deliver action mail or email. So with that, in 2 weeks, they've been able to track down payment issues it's just like 10 lines of Ruby. Some people are selling that for 10,000 euros. True story. Before I end up, I want to share a few what we call, it's more to give the word change data capture. It's a buzzword to say that you're able to only pick what changed in your source system. So here are a few tricks I want to share with you. If your data is immutable, like in, say, I think Google Analytics or things like that, you can extract only what is more recent with the created at or the ID. If you have data that change, it's getting more complicated. You have to go create that and modify that, so you pick all the records that change. And if you want to handle the deletion as well, it can become much hairier as well. So you can mark as deleted in your source system, so you can actually notice that the rows are deleted, so you can delete it in the destination as well. And you can use a list of deleted IDs or row checksum for more advanced behavior. So if you want to talk more about advanced trick, like I said, feel free to ping me up, because I know a couple of people are interested in the room. Voilà. Do you have any question?
First of all, I just want to say thanks, because Thibaut is the kind of person that you want involved in your open source project, because he picked up Active Warehouse and ran with it, and it would have just died on the vine, but he's really done great things with it. I'm actually curious, what's the plan for the other part of it, which is the actual data modeling part of it?
Well, it's the same story as the main, because there is a second part to the project called Active Warehouse, which is an OLAP implementation in Ruby. And the story is that people are using it in production right now. It's just on GitHub. But the test coverage is fairly hard to bring back to life. And so it would require a fairly large effort. So I'm ready to help people do it, like put things on Travis, initiate the documentation effort and stuff. But I think that my opinion is that it's much easier to go to Mondrian or specialized solutions. But I know people are using it in production, like companies like PRX, using on hundreds of millions of rows, literally. So.
Yeah, thank you, Thibaut. It was a very interesting talk. I've got a question about testing. You said you were test driving, and in the example where you have a Spanish Java application talking to the old COBOL dude, how fast are your tests? Do you use the real system to work? Actually,
it's a fairly good question. It's the question of when you use Rails or not, or you use validations or not. It's a recurring discussion. So these are really unit tests. So they are separate from the data. So I put mock data that I grab from the real system to make sure my system works as expected based on the situation that I knew at that time. But there is another kind of test. And there are two kinds of tests. It's more like the screens that you saw earlier. Mm-hmm. Like, I remember. You remember? Okay, fine. Thanks a lot. So the screens are actually the, so to speak, the test equivalent to real live data. Yeah, so you can end up doing two kinds of tests in those screens. You can pick up one row that you know to be in a specific state and do things on it to ensure you didn't mess up how the import works. And then you can have more group tests, like make sure that this column, unique, is always in that kind of, is always equal to this. So you can have tests on the specific record, which I call sampling testing, and the overall sanity checks. But you can go even further. I know some people have been doing quality tests. Basically, you can, if you go with through the raw pipeline that I described, you can provide some fairly advanced, complicated tests, including statistical, complicated cleaning, and then you can build a PDF report for people to act on it on the field. So some people are doing that. As well, to completely answer your question, because nobody wants to have crappy data in production, one solution is to use a staging area. So you have your the big database, which is the result of all your consolidation, and you can create temporary tables that are the same, that have the same schema, load the data in there, maybe without any active record validation, do the test on that specific bits, and then merge using the merge commands of your database, merge upsert to your real database. So it provides a fairly strong and very agile sanity checks on your data.
Thank you.
Thank you, and feel free to ping me if you want to discuss more advanced topic as well. Yep. Okay, whatever.
All right.
Have a good lunch.